All right, good morning, everybody. Welcome to ACES, Introduction to Data Science in R. My name is Wes Brashear, and I'm going to be the instructor today. I am an assistant research scientist here at High Performance Research Computing at Texas A&M University. My background is in genomics and bioinformatics. So I've got quite a bit of experience using R in regards to things like life sciences workflows. So doing things like RNA-seq and differential expression analysis, generating graphs for publication, some general data science that's more of a biological skew to it. So what we're going to be covering today, just a brief outline. The first will be covering ACES or accessing ACES. We'll be doing that through the portal, and I'll be showing you around the portal a little bit, showing you the different ways to access the cluster through the command line, or getting to the command line through the portal, how to search for files, and how to launch the interactive Rstudio app. Once we get that launched, we'll open up a notebook that I've created covering these different topics, including different data structures in R, how to work with them, manipulate them. We'll cover a brief introduction to tidyverse, and then dive into using the dplyr package. Next, we'll be going over importing and exporting data from things like Excel spreadsheets. And then following that, we'll be doing some regression analyses, principal component analysis, and then we'll end on data visualization with ggplot2. So the plan is to have two sessions. So a morning session going to about 12:30, and then an afternoon session going from 1:30 to about 4. And we'll have breaks in between. The way I like this course set up is, or the way I like the courses to run is that for them to be as interactive as possible. So if you have any questions, feel free to interrupt me or post something in chat. I'll be keeping an eye on chat. Josh, my colleague, has just posted the slides for today's short course, which is really just this brief introduction. And then we'll be getting to the R notebook, which you'll have access to even after the class. So again, feel free to interrupt me, ask questions. If you're having issues, definitely speak up. There's people here to help from HPRC. If you get stuck on a certain process or need help, we can make sure that happens. All right, so the first thing you'll want to do is navigate to hprc.tamu.edu. Went ahead and threw that in the chat. And once you get there, you can navigate over to the portal drop-down menu and then click on ACES Portal Access. So I'm going to go ahead and do that. So hprc.tamu.edu, hover over portal, and then click on ACES Portal Access. All right, so I'm automatically logged in. You will likely have to go through and do the identification through Access, but I already logged into Access this morning. So it should pull up a page like this and allow you to select the appropriate identity provider. And then once you've done that, then you can log in through Access with your Access ID and Access password. All right, I'm going to give everybody a minute to get logged in. Can I get a thumbs up and if you've been able to get this far? All right, Paige, it's good. Lauren, it's good. Marty. All right, please speak up if you're having an issue accessing ACES or if you need help. All right, Peter, so if you're on hprc.tamu.edu, you'll go over to Portal, and then just hover over that, and then the drop-down appears, and then you can go to ACES Portal right here. And if you click on that, then you can follow all the steps to log in through Access.
Okay, I'm just gonna do that.
Okay,
Yeah,
excellent.
thank you. Yeah.
Okay, Rick, you haven't created an Access account yet? Yeah, you'll need to do that in order to access the materials for the class. So if you have not created an Access account, that is one of the requirements for the class is a Access ID. Please go ahead and do so. If you've created an account but haven't provided your username, Access username to HPRC, then please share that with us in chat. We can add you to our training allocation. Josh has provided a link to directions on how to get an Access ID. Have a brief walkthrough. All right. Well, so this is our ACES portal view. And I'll just give you a brief walkthrough. I think we have a lot of first-time ACES users registered for this course. So this may be the first time that some of you are seeing this. We have a drop-down menu for things like the files. So here we can navigate to either our home directory or our Scratch directory. So if I click on this, it'll bring up a nice interface with all of my different directories and files inside of my Scratch space. You can do things like edit files in here. If I click on, let's see, maybe there's a text file in here. I can do things like view or even edit the file. So this is a real nice user interface for doing things, small manipulations of files, if you're not comfortable doing so on the command line. We also have things like we can see which active jobs we have going on. I don't have anything running on ACES right now, so there's no active jobs. A bunch of interactive apps. So these are things like GUIs that will be running on compute nodes on the system. So VNC for just kind of a regular remote desktop view. Things like CryoSpark, ImageJ, Jupyter Notebook, and Jupyter Lab. We'll be using this Rstudio short course today. And then right here in clusters, if you'll go ahead and click on clusters, and then ACES shell access, that should give you access to the command line and that terminal view. So go ahead and do that. We're going to copy over some course materials so that we can use them. Can I get a thumbs up whenever you've managed to get the terminal view? All right. All right, so the next step is to copy the contents from Scratch/training/data science R to your home directory using the CP command. And then change your directory to data science R, and then run the ls command. And these are the files that you should see. Let me modify that. These are the files that you should see. So I'm going to go ahead and put these commands in chat. All right, so clear this out. I'm gonna run CP, make this bigger. All right, can everybody see that? Is the size of the text okay?
Yes.
All right, thank you very much. All right, so CP space dash R. So we're gonna grab everything recursively, scratch, training, data science R, and then space period. We're gonna copy it to our current directory. We wanna change our current working directory to the one that we just copied, and then list the contents. And so we can see we've got carnivores.csv, carnivores.xlsx, data science, and r.rmd, and data science.xlsx. Is anybody having issues with this so far?
I have a question. Are we supposed to delete and then type in what you have? Like when you go to the like the top of mine says warning permanently added login, blah blah blah, all that stuff. Do I delete that?
You can run so yeah, to clear the terminal space, it doesn't really matter. I just did that to make it easier to view, but you just type in the command clear and it gets rid of all of that. And so it just makes it easier to see. It doesn't affect anything. So that's why I did that. Control L also clears screen if you like keyboard shortcuts. All right, thanks, Josh. That works in Rstudio as well. All right, any other questions? That was a good question. I rushed through that. All right. So we're going to go back over to our all right, so real quick, Rick, if you go to the clusters and then ACES shell access, that'll pull up this, and then you can run those 3 commands I posted in chat right above, and that'll catch you up. All right, awesome. Okay, so I'm gonna go ahead and leave that space. I'm gonna go back over to the on-demand portal view. I'm gonna click on now interactive apps to pull up the dropdown, and then go to Rstudio, and then parentheses short course, and click on this. All right, so this will bring up a lot of different options for you to pick. You can do 4.2.2 is the R version, that's fine. Number of hours, just put in 7 here. That way this session's active until later today. We only need 1 core here and about 5 gigs of memory. All right. Once you have those set, you can just click launch. And that will bring up this view here and asking us to be patient as our job's currently sitting in the queue. We shouldn't have to sit in the queue. This has been added to a reservation so we can ensure that there's enough cores available for everybody, and we should be able to just hop right on once the session is started. All right. Once the session's ready, you'll have a button that says connect to Rstudio. So once you see this connect to Rstudio button, you can go ahead and click on that. All right. Can I get a thumbs up for the people from the people that have been able to launch Rstudio and have this view?
Is it okay if my view doesn't show the system library that you have?
Uh,
So in the
where-
bottom right, it says system library. So I'm opened up an R, but mine just doesn't say system library with all those
all right.
items.
What does yours say?
Mine says files.
Oh, yeah. I'm sorry. Click over. So yours looks like this more.
Yes,
All right. Yeah. If you just click on packages.
packages. Okay, perfect. Thank you.
Yeah. And we're about to do a tour of Rstudio. So good question
Okay.
though. Yeah.
I this doesn't look exactly the same.
All right, so this is Rstudio, and this is exactly how it looks on your desktop as well. But the difference is that this is running on one of our compute nodes. Now, we only selected to have one CPU and 5 gigs of memory, which I imagine you all have laptops or machines that can do better than that. But since we're just doing some very simple stuff today, we're not really requiring that much power. But if you're doing some sort of analysis that can be threaded across multiple CPUs or requires a lot of RAM, you can really increase this to something like several hundred gigs of RAM if you need that. 96 CPUs or something like that to speed up your analysis. So that's really where the power comes in is once you've become familiar with R and doing all these things, if you have an analysis that requires more power than is available on your own system, you can run in the same environment that you're familiar with or on one of our compute nodes that has a lot of power. All right, so up here is the console. This is where we can type in R commands. So if I just type in like an R command git wd, it shows what my current working directory is. So right now I'm in home and then my ACES username. If I click over one tab, it brings up the terminal. And so I can do things like here, ls. I can, again, go into that data science R. And if I type in ls, it shows all of these files that I copied over, right? And so it's a nice little, instead of having to hop back over, to terminal over here, it's already inside of the RStudio server. Over here on the bottom right in this pane, we have things like a file browser. And again, we can go into data science R, see the files in there. This is also the pane where your plots are going to show up. So if you click on plots, we don't have any plots right now, but that's where those are going to display. If you do run something that's going to plot out or produce a plot. Right here, under the packages tab, we've got all of the different R packages that are available. And this is what makes R so powerful, are all of these packages that can be installed to extend its functionality. And a lot of these are going to be discipline specific packages. So like I said, I'm from the world of genomics and bioinformatics, and there are a lot of R packages that are written specifically for pipelines within that field. And the same thing is going to be applied for people like in economics or maybe people in engineering or and so forth, or just extended statistical packages, things like that. So like the users that registered for today come from a broad range of backgrounds and disciplines, but there are going to likely be packages that are available to you for your specific field of study. And what I hope to get you through today is a level of comfort where you know kind of the basics of R enough that you can start using those packages and really understand those packages better, and just be able to work more comfortably in a space. We have a nice help file here, so we can just type in whatever we'd like to find help on, and it'll bring up different usage objects or different usage, how those different commands are utilized, some of the different arguments for those commands, and then details about the particular function or package that you searched for. All right, up here, we have our environmental tab, which is going to hold things like variables that we've stored. So if I do something like, I'll show you, explain this more in a little bit, x equals 3. So it should pop up here. Interesting. That may be if we're only if you're running jobs up here. Let's see. Okay, yeah. So whenever we're running jobs from like a job script, then the values are going to for those variables to show up here. What we've got kind of saved in memory that can be worked with further down in that job script. History is just going to show all of the past commands that I've run. You can see I ran x equals 3, get wd, and all of these different commands earlier. All right, I think that's good. Are there any questions on the Rstudio interface?
Yeah, thank you. Sorry, I missed the very first step, and I guess that's why when I clicked on the files, it seems empty. So I'm thinking maybe because I missed the very first 3 lines of command. But I'm right here on this page, but I mean I mixed the first 3 lines of command. So maybe that's why my files are empty, sort of.
All right, so let's get this sorted out. And again, if anybody else is having issues like this, we need to get this sorted out, because if you don't get these files, then you can't do the rest of the tutorial. So we're going to take time and make sure everybody has what they need. All right, so if we go to let's say terminal right here, if I do ls, that's going to list all the contents that are in just my home directory. Actually, whenever you type in pwd in the terminal, what does it say?
I typed in the pwd and I have home/u/pa. I guess that's my directory.
Yeah. All right.
Yeah.
And then you type in, if you type in ls, do you have this directory right here, data science R?
No, I don't.
All right. So then you'll need to run this command cp/r/scratch/training/data science R space period.
Yeah, I did that, but I have sorry, I have CP missing destination.
Did you put the space dash period at the end?
Oh, okay. I think I
Yeah,
missed
so
it.
that I know it's you need to specify where you're copying the directory to. So here we're saying copy and then copy the contents recursively, meaning grab everything inside of it. The source, which is scratch/training data science R, and this period represents the destination, and that means your current working directory. All right, well, I'm assuming because I lost Josh and Peter that they're in the breakout room. All right. So the next thing we need to do now is go to File up here and click on that, and it'll bring up the drop-down menu, and then click on Open File. Then navigate to the Data Science R folder. Click on the Data Science in R.rmd file and click Open. All right, this is a special R Markdown file that runs with a package called Learn R that generates a interactive notebook that will allow you to open the notebook and then run all these different kind of hands-on exercises and independent activities. And so you can see it's quite long. This one's about 1,500 lines of text or code. But if we click Run Document up here, it will process this and then open up a notebook with a much nicer user interface. All right, you may get an error or a pop-up that says pop-up blocked, and that you've attempted to open an external browser window, but the action was prevented by pop-up blocker. Just click Try Again, and the workbook should open up in a new tab. All right, so now that we've gone through all of that, let's actually start learning some R. Before we do though, I just want to make sure that the text size is okay for everybody. You can see it on your screen. All right, well, since nobody's complaining, I'll take that as a positive. All right, so the first thing I want to jump into are data structures in R. And so there are quite a few different data structures available, and we'll be using different ones for different data science applications. The first and the simplest structure is what's called a vector, and it is a one-dimensional array of elements of the same fundamental data type. All right, so we have different data types in R, which makes sense. So things like logical data, which is true and false, numeric data, which includes whole and decimal numbers, and then character data, which is things like text, right? So strings. Vectors can contain multiple elements, inside of them, but they all need to be of the same type, right? So you can have a vector that contains all numeric types, all logical types, or all character types, but you can't have really a mixed vector. We also have lists in R, which are essentially just a collection of different element types, and you can have all sorts of different things in lists, right? So you can have a numeric type. You can also have like a vector that's part of a list, a matrix that's part of a list. So a list is a much more kind of inclusive, just kind of grouping of different types of elements. A matrix is very similar to a vector in that it must contain elements of all the same data type. So probably like the least, I would say it's the data structure that's maybe not used as often as the others, because it's really restrictive as far as what data it can contain. But it's like a vector, except it's got it's multiple dimensions, right? Meaning it's got rows and columns. A data frame is probably one of the most common types of data structures that you're going to run into in R. It's a group of elements arranged as like a table or a two-dimensional array that can contain different types of data, right? So you can have one column that's numeric data, one column that's string data or character data, another column that's Boolean or logical data. And so it's very similar to how you may be familiar with working with data in the past, and like a spreadsheet or something like that. So a data frame is something that will definitely be using for a majority of this class. A tibble is much like a data frame. Oftentimes you won't know the difference, or you won't know that you're working with a tibble rather than a data frame. It's just kind of a more opinionated, kind of modern reformatted version of the data table that's specific to the tidy universe, right? So there's some small differences that we'll discuss later, but really you can consider the data frame and the tibble overall is kind of the same or very, very similar data structures. So those are the two that we're going to be working with for most of the day. When it comes to actually starting to look at these different data structures, there are some commands that are useful for all of them. So that are shared between all of them. So for instance, the functions print, head, and str, which would be like the structure, those are all useful for examining the contents of a given object. So in this code chunk below, this notebook is going to be set up like this, where there's going to be some explanatory text, and then a code chunk that actually allows you to run some sort of R code. So in this code chunk here, we are going to run these three commands: the str structure command, the head command, and print command on this built-in data set iris. All right, so we'll just click run code here. All right, and so the first one we ran was structure. So we can see that this is a data frame that contains 150 observations, so essentially 150 samples with these 5 different measurements or variables. So the sepal length, the sepal width, the petal length, the petal width, and the species. Head is a command that just prints out the first few lines of a data frame. So here we're printing out the first 6 rows of the iris data frame, and it's showing us the values for each one of these columns, and these all come from the iris species setosa. And now when we print, though, that's going to print the entire data frame, right? So this is a relatively small data frame. It's only got 150 observations. But if you were to run this like in the R console, this is going to print out everything to screen. So if you have something that's like 2,000 or 3,000 lines long, you may not want to print the entire data frame. You'd want to use like something like head to just print out the first few rows to get an idea of the contents. All right, are there any questions? All right, so now what I want you to do is take like 30 seconds and try typing those commands on the built-in data set mtcars. All right, so the first command, str on mtcars. If we run this, we can see it's a data frame with 32 observations of 11 different variables. The next command, head, shows that there's these different types of cars: the Mazda RX-4, Mazda RX-4 wagon, and these different variables: the miles per gallon, the number of cylinders, the displacement, which is the engine size, horsepower, the DRAT, I don't know what that is, WT, the quarter mile time in seconds, PS, and so forth. All right, and then the final command, again, print. Gonna print out that full thing. All right. If as we're working through this today, if you get stuck on something as the exercises start to get more difficult, you can click on solution and it'll pop up the solution to the independent exercise. All right, so let's go ahead and move on to vectors. And again, these are just one-dimensional arrays that contain collections of the same data type, right? So we can have either, we have a vector of just logical data, which would contain just true and false values, integer data, which in R we specify integers by following the number with an uppercase L. I'm not sure of that, where that convention came from. Numeric data, which can contain decimals or whole numbers. And then finally, character data, which contain text or strings. So to create a vector in R, we can either do something like subset part of a matrix, a data frame, or a tibble, or we can create it from scratch using something like the C function, which is combine or concatenate function. So here in this code chunk, I'm creating a new vector named numvec, right? And I'm assigning it, right, the output of running this command, which is the C function or combine function, and then all of these numbers, right? So essentially just providing the array that we want to have saved inside of this variable numvec. And then I'm using the str function to print out the structure of it. Oops. There we go. So we can see it's a numeric vector going from indices 1 to 8, containing these 8 different elements. Is R space sensitive with the equal? No, R is very forgiving with spaces and things of that nature. So if we do this, nothing changed, but the output's the same, right? So just to make sure, right? So having the spaces here, it doesn't matter, but it is I guess a matter of aesthetics. I don't know. I think it's easier to read and cleaner with the spaces in there, but if you prefer no spaces, that's a personal choice. All right. So we're going to use the code chunk below to create a new vector that contains the days of the week. We're going to save the vector as a variable named week and examine the structure using str. All right, so I'll go ahead and do this one along with you guys. So we're going to set week equal to the results of the combine or concatenate function and start off just naming the different elements we want. Now for character data, we are going to have to wrap those in either single or double quotes. So I'm just going to try this. So if I try running this, it's going to tell me object Saturday not found. All right, what does that mean, object Saturday not found? What was it trying to do?
Oh, you didn't put it in quotes?
Yeah, I didn't put it in quotes. So exactly. So, but what's it looking for then if it's not in quotes?
A variable?
Yep, exactly. So it's looking for a variable named Saturday, and it's not able to find it because we didn't define it. So we have to include for character data like this, if it's not in quotes, it's going to assume that you meant a variable. That's just perfect, Lauren. That's exactly what I was after. And so now we can see, since I included the quotes, that we've got this vector that includes the days of the week. All right, any questions? All right, so let's try this. All right, do we think this is going to work? All right, so this works. Again, back to Rick's question about, is this space sensitive? Ours is very kind of, let's say, liberal with some of these conventions that allows you to do. So as long as your line is ending with a comma, it will move on to the next line to look for the next element of the vector that you're trying to create. If I try to run this though, then I get this error because I removed the comma from after Friday. And so it wasn't able to go to, it was expecting something between these two elements, that comma, and it wasn't able to find them. So run code, and it works again after putting that comma back in. So this is useful whenever you have like really long commands. This works, outside of just doing creating vectors. You can have commands that go on to the next line. That's fine. Typically, those you're just going to end your line on a comma and move on to the next part of the command, and so that may help with readability of your code. All right, any questions? All right, so let's move on. I know we're starting off slow. We'll ramp up, so don't worry. Once we get to dplyr, that's where I think things start to become a little more challenging and fun. For subsetting vectors, we can use the square bracket notation. And what this allows us to do is essentially choose the index of the element or elements that we want from a vector and just evaluate, pull those out, or run a command on those. So here we're printing our week vector that we created again. And then here we're printing the first element of the week vector. So if we run this, we can see our full vector includes all the days, Sunday through Saturday, and then print week. And then following week, we did open square bracket, the number of the index for the thing we wanted, the element we wanted to print, close bracket. And then we closed the parentheses. And so it pulled out just the first element. All right, are there any questions on how that works? All right. Does anybody have experience with other languages, maybe like Python? Yeah, thank you, Jason. That was exactly what I was asking about. So Jason said I was kind of expecting it to start with 0. So R is the index is 1 based, meaning that the first element is an index of 1. Whereas with Python and a lot of other languages, you may get the first element may correspond with index 0. So that is something that definitely needs to be pointed out. It's if you're familiar with other languages, this likely throws you. Or if you're gonna, go from R to Python, that's something that you need to be aware of as well. So it's not that one's better than the other. It's just a matter of convention. So here we have a one-based index. Thank you, Jason. That was you read my mind. Okay. All right, so I'm going to throw a little bit of a curveball at you. To select multiple elements, we would have to provide a vector of index numbers. So we could do something like create a vector with C and then provide all of the elements we want, or select a range of elements using the colon operator. So I'm going to give you a minute or two to try to complete this independent exercise. First using the C function to print out the first 3 elements of the week vector, and then using the colon operator to print out elements 4 through 7 of the same vector. All right, so to access or to subset just the first 3 elements, we're going to, print week, and then in square brackets, we just do 1, 2, 3, close square brackets, and close out week. All right, and then next, why don't you like that? Oh, missing a parentheses. All right. Next, we'll do print week, and then in the square brackets, we can just do 4:7. And if we run this, we should print out Sunday, Monday, Tuesday, and then Wednesday, Thursday, Friday, and Saturday. All right. So again, these function the same, right? It's just a matter of what you prefer using, the colon operator or the combine function. If we want to drop elements of a vector, all we have to do is include that vector or include that index of the element we want to drop with a dash in front of it. So essentially minus the index number. So here, if we remove elements 2 through 6 and we click run code, it should only print off elements 1 and 7, which would be Sunday and Saturday, which would be the weekend. All right. Any questions? Can I get a thumbs up if everybody's happy and following along? Thank you. Thank you.
Question.
Of course. Let's hear it.
Is there a way to index while you're also removing things? So like in line 1 where your cursor is, can you use the colon somewhere in there to kind of reduce having to type out all of the numbers?
Oh, so you want to remove multiple elements, but using the colon operator?
Yes.
Yeah, that's a good question. Let's see. Well, let's just try. I don't know that this is going to work. I don't think this is, but let's give it a go. Oh, my word, it did work. Okay, yeah, so you can just do that.
Perfect. Thank you.
Thank you. All right. I was really edgy. I did not think that would work, Lauren, so thank you very much. Now we know. All right. All right. What's the other way of doing this, I suppose? I guess if because contextually, I wouldn't think about it that way. I would probably do something like that just to pull out the elements I did want instead of removing the other ones. But that wasn't the point of the exercise. So, all right. All right, so we can also use the same kind of syntax to replace elements of a vector. So in this right here, I've got a vector called birds. I'm going to print it out, and then I'm going to assign this, the great blue heron, to replace the second element of the birds vector, and then I'm going to print it out again. All right, so here in the first time, the common grackle was the element that we wanted to replace, and we replaced it with great blue heron. All right, and again, it was just by specifying the index that we wanted and the value that we wanted to replace it with. All right, Peter, are we going to have access to the recording? Yes, Peter, so we'll put this recording up on our YouTube page. It does take several weeks to compile and get everything ADA compliant. Yeah, so it's a generally slow turnaround time, but it should be available probably within a few weeks. All right. Is everybody comfortable replacing grackles with herons? All right. I don't know if you guys have grackles in your grocery store parking lots, but we have them here in College Station. It's like a swarm of them. But I guess a swarm of great blue herons would probably be worse. All right, so in this independent exercise, we are going to create a new vector named clusters with the elements ACES, Faster, Grace, and Terra. We're going to print the structure and maybe the contents of the vector. Then we're going to replace one of these elements with launch, and then print the contents of clusters again. All right, so here we'll just do clusters is equal to, and then I'm going to use the C function. I'm going to say ACES, which we're all on right now, Faster, Grace, and Terra. Then I'm going to get the structure of this clusters, and this is such a small vector. Just typing in structures will print all of the contents. We don't need to add in an additional print statement. And now we want to replace Terra with launch. All right, so this is 1, 2, 3, 4. So we can say clusters right here, 4 in square brackets equals launch. And then we'll do str on clusters again and run to see the results. All right, so here we've replaced, this is a list of clusters that we used to maintain here at the HPRC. Terra was recently retired, but we have the new cluster launch that was recently deployed. And so we've updated that here. Any questions? All right. Now, let's move on from vectors to data frames. And for subsetting data frames, it's very similar syntax, except for now we have to account for both rows and columns whenever we're subsetting. So if we want to subset the element from the second row and the fourth column, we'll need to put in the name of the data frame, and then again in square brackets, row 2, row goes first, and then column 4, following after a comma. For multiple rows and multiple columns, the rows are going to be separated by a colon, so 1 through 2, and comma, columns 5 through 6. All right, now this is where it starts to look a little weird. If you want to select just, the first 2 rows, but get everything from all of the columns, then you would do 1:2, comma, and then blank. All right, but this comma tells it we're looking at here rows, right? Rather than it trying to access this maybe as a vector and pulling out just the first 2 elements. All right, another really handy bit for pulling out columns from data frames is the $ operator. This is something I use all the time. So if you want to pull out, if you have just like a specific column that you're interested in grabbing, you can do the data frame name, $, and then the name of the column that you want, and that'll just pull out the entire column. So this is something that you see used quite a bit in R. It's a real handy operator to know. So in the code chunk below, we're going to use the built-in empty cars data frame to complete the following steps. We're going to look at the structure in the first few rows of the empty cars data frame. Select the first 2 rows of empty cars data frame and save it as a new variable named Mazda. And then we're going to print the contents of the new variable. And then select the first and second elements of rows 4 and 5 and save the output to the variable Hornet and then print the contents of those. So I'll give you a minute or so to work on that. And then we'll go over the solution. All right, so for the first step, to look at the structure, we'll use the str command again, or function. And then just to print out the first few rows, I used the head command. And then for the second step, creating a new variable named Mazda, I'm subsetting the empty cars data frame using the square brackets, specifying rows 1 and 2, and then ending that with a comma. You can see that learn R doesn't like this, but this is okay. I'm going to print the contents of that. And then Hornet, I had to specify rows 1 and 2 and columns 4 and 5, and then print that to screen. So if I run this, first we see the structure again of empty cars, which is a data frame with 32 observations of 11 variables. We have the first few rows of this data frame. And then our Mazda variable, which contains the Mazda RX-4 and the Mazda RX-4 wagon. And then the Hornet variable, which contains just Mazda RX-4 and Mazda RX-4 wagon, and then those 2 elements. Is there something amiss? Oh, I did it backwards. The first and second elements of rows 4 and 5. How poorly worded that was. My apologies. All right, so now we've got the Hornet 4 drive and the Hornet Sportabout and the miles per gallon and the cylinders. All right, that's an easy mistake to make. All right, any questions? Is everybody comfortable subsetting vectors and data frames with square brackets? All right, excellent. Thank you, Lauren. Thank you, Rick. All right, we're gonna go ahead, I guess now, let's go ahead and we've been at it for 1 hour and 20 minutes. Let's take a 10-minute break. We'll be back at 11:30 and we'll continue on with data structures. If you have any questions, you can post them in chat and I'll answer them too. All right, thank you, everybody. We'll be back in 10. All right, welcome back, everybody. Let's move on to a new function called the subset function. This is another way for us to essentially subset data frames. But here we're going to be using essentially conditional operators to make this selection, right? So it gives us a little more power of how we want to subset the data. So for instance, if we were going to subset that iris data set, we could pull out all of the samples for which the sepal length was greater than 5, or if we wanted to pull out only members of a certain species, we could subset, use a subset function here and provide the species that we want being equal to Virginica. So the way this works is we have our subset call, and then open and close parentheses, and then we give it the data frame that we want to select from, comma, and then the conditional expression that we want to evaluate. So here we're saying sepal.length, that column name, the value is greater than 5.0. Here we're saying species we want is going to be equal to Virginica. And here we're having to use the double equal sign as the comparative operator. Otherwise, it thinks you're trying to assign a variable. All right, so now what we want to do is in this exercise is create a new data frame by selecting all of the cars in the NT cars data frame that have 6 cylinders. Next, create another data frame of all the cars with at least 250 horsepower. All right, so I'm going to start by just doing a quick head command on this to take another look. All right, so we can see we have this CYL column. So I could say 6 CYL is going to be equal to the results of this subset function, and I'm going to be pulling from MT cars, and I want CYL to equal 6. So if I go ahead and print this, let's run. All right, so now you can see that only the cars with 6 cylinders have been included in this new data frame. All right, now for all of the cars with at least 250 horsepower, I can say something like high horse is equal to, again, the result of the subset function for MT cars, where HP is greater than or equal to 250. Print high horse. All right, I've already run the first 2 lines. Does anybody know how I could maybe make it to where I can keep those lines but not have the commands run? Well, to do that, I know I didn't teach you guys this, so I just wanted to bring it up. I can just put a hashtag or a pound symbol in front of that. And now I can keep this code of, or this line of code in here. It won't be evaluated though by R, so that won't be printed to screen. So the only thing that should be printed is the result of high horse, which prints out this much smaller data frame that includes the Ford Pantera and the Maserati Bora. One with 264 horsepower and one with 335. All right, any questions on using the subset function? All right. Well, then let's move on to Tibbles versus data frames. So I'm going to kind of go through these. This isn't something I expect you to memorize by any means. And they function, as I mentioned earlier, Tibbles and data frames, a lot of times they function identically, but there are a few small differences that you may notice. So I just wanted you to be aware of those as we move forward and we start seeing maybe more Tibbles instead of just data frames. Tibbles are really popular in the tidyverse suite of packages, which includes dplyr, which we'll talk about in the next session, ggplot2, which is we'll cover in the final section in tidyr. But the difference is, first of all, using the print function will only display the first few rows of a tibble, whereas all of the rows of a data frame will be displayed. So if we're trying to do like print on a large data frame, it's going to take quite a bit of time to print all of the contents to screen, and it will take up a lot of your screen space that you'll have to scroll back through to find whatever you're looking for. Whereas with tibbles, it functions more like the head command does with data frames, printing out only the first 10 rows. Whenever we're doing subsetting and using things like the $sign operator, tibbles are far more explicit and will not conduct partial matching, which is something that I do like, and I'll show you an example of that in a minute. Whenever we subset with square brackets on tibbles, it always returns a tibble. It doesn't, even if we only select a single row or a single column, it's still going to be a tibble. It's not going to return a vector. Tibbles do not alter input types. Tibbles only recycle vectors with a length of 1. And I think I've got an example of that coming up. And lastly, tibbles cannot generate the names of rows. So just a few small differences. Other than these, they're pretty much identical. So what we're first going to do is convert empty cars data frame to a tibble and kind of examine how the two structures differ. So here we've got the empty cars data frame as a, we're saving that just as is a data frame. Here we're converting it to a tibble using the as tibble function. And then lastly, we're going to print both objects. Oops, highlighted. There we go. All right, so again, major difference here. We have some additional information whenever we print a tibble, like the overall size of the tibble, the data types that each of the columns contain, and it's only printing out the first 10 rows. Whereas print with the data frame type object just printed out everything that was contained inside of the data frame. All right. Now, if we look at how the results of subsetting the data frame versus a tibble, we can see that here the structure, we're selecting for data frame 1 through 4 and 1 through 6, rows 1 through 4 and columns 1 through 6. We're returning another data frame, but here we're returning again a tibble. Now, if we that's reasonable, right, and understandable. But if we do the same thing with a data frame and only selecting here a single row, it's going to print those out, and then it actually returns a vector whenever we're subsetting a data frame. Whereas, again, if we're selecting a tibble, it will return a tibble, even though it is a one-dimensional tibble. All right, and then lastly, a demonstration of that partial matching. If I run this here, it's going to, on a data frame, conduct partial matching. And what it's actually printing out is the MPG column of data, whereas with tibble, it gives us this warning, unknown or an uninitialized column MP. Right, and I prefer this method because it makes sure that what you are typing out or what you're requesting, it's explicit, and you're not going to get some results that you're not expecting by conducting this partial matching, right? So this is the way I think it should behave, and so for that I give the bonus tick to tibbles for behaving what I believe to be correctly. All right, any questions over the differences between tibbles and data frames? All right, can I get a thumbs up if we're ready to move on to mathematical functions? At least some of our people are still there. Good. All right. Thank you for the thumbs up. All right. So a lot of these are very straightforward. The mathematical functions. So we have things like our mathematical operators include what we'd expect, like plus signs, minus. Multiplication is done with a asterisk. Division a forward slash. Exponents are done with a hat. And then finally, to get the remainder after division is with 2% signs. So there's a heights vector. You can take a minute or so and go through and just kind of do some random calculations using the heights vector, and just to get familiar with the different operators. No, I've been signed out. What happened? All right, so we've got this vector of heights going from, I guess, 1.45 to 2.04. All right, Jason, you got signed out as well. If you just go back to the portal and where it says My Interactive Sessions. Okay, something happened on our system. And just connect to Rstudio, and then you can relaunch the notebook. All right. Rick's back in. Jason, are you back in?
Not yet. Get in there.
All right. All right, so if we do something like heights times 2, what it's going to do is multiply each element of that vector by 2, right? Same thing with heights plus 2, right? Or heights divided by 2, right? It's performing that element by element, right? So that it's doing whatever the mathematical operation you want. It's going all the way down the line. But if we do something like use 2 vectors, then this is going to change the behavior of R a little bit. So in this independent exercise below, go ahead and use this code chunk down here to follow these steps. So first create a numeric vector named numvec1 with numbers 1 through 6. And then another numeric vector, numvec2, with numbers 7 through 12. Multiply 2 vectors together and examine the results. Then remove the last 3 elements from numvec2 and multiply the vectors again and examine the results. And then finally remove the last element from numvec1 and multiply the vectors one last time. So we can do numvec. Jason's back in, excellent. Numvec1 is equal to C1, 2, 3, 4, 5, 6, 7. Numvec2 is equal to, I'll just do print. All right, so now we've got these 2 vectors of equal length. And so if I multiply them, let's say numvec1 times numvec2, Oh, I included a 7 up there when I shouldn't have. All right, so now we've got our first vector 1 through 6, our second vector 7 through 12. And then when we multiply them, it's going through element by element. So now we're doing 1 times 7 is equal to 7, 2 times 8 is equal to 16, 3 times 9 is equal to 27, and so forth. So it's doing, now it's going down the length of each vector and doing the multiplication by those element indices. So if we remove the last 3 elements from numvec2 and multiply the vectors again, so we'll do numvec2 equals numvec2 1 through 3, and then multiply again. All right, so after we've removed the last 3 elements from vector 2, the results changed. So here what's happening is now it's recycling through this vector essentially. So 1 times 7 is equal to 7, 2 times 8 is equal to 16, 3 times 9 is equal to 27. Now, however, that's where the second vector ends, now that we removed it. And by recycling that vector, we mean that it's going to go back to 1 here. So 4 times 7 is equal to 28. 5 times 8 is equal to 40. And 6 times 9 is equal to 54. All right, does everybody, Rick, we'll get to that in just a second. Does everybody see what happened here? The recycling of the vectors?
Sorry, excuse me. The line 9, can you see when you have a vector 2, I don't know how you multiply the one in the code in the square bracket.
Okay, so here,
Yes.
let's run this again. So all I'm doing here is I'm assigning the value of numvec2 to be equal to the original numvec2, but only the first 3 elements of it, using those square brackets to subset it. So essentially removing the last 3 elements. So the same thing would have worked with, right? So to remove those elements, we could do -4 through -6, and that will work as well. And so we've got a new numvec2 to multiply against down here. So here it's 1 times 7 is equal to 7, 2 times 8 is 16, 3 times 9 is 27. But then we're out of elements here, so we have to recycle it and do 4 times 7 is equal to 28, 5 times 8 is equal to 40, and 6 times 9 is equal to 54. Did that clear it up, Elizabeth?
Yep. Thank you very much.
Yeah. All right. So now if we do a similar thing, but just remove the last element of numvec1, and print again, or multiply again. All right, so this time it still runs the code but it's saying there's warning numbec2 times numbec1 times numbec2. The longer object length is not a multiple of the shorter object. Right, so it's still recycled, but it wasn't able to make it all the way through the shorter list a second time. So it only partially recycled. And the point is that it will still recycle and still produce results, but it may not be what you're expecting. So just something to watch out for. All right. Any questions on that?
No question here.
All right. All right. And then, okay. So, let's see. Rick, I don't, when printing multiple variables, can you do something like Python? Let's try. I don't know if this will work. So there is a way to apply functions over multiple for multiple arguments. I'm not sure how to do it off the top of my head, Rick, but there should be a way to do it. So Rick was trying in Python, you can essentially just print multiple variables with a comma separated. But I'm not quite sure how to do that in R off the top of my head. So I guess if you just provide it as a vector. Nope. It'll combine them like that. Yeah, Rick, that's the best I've got. Cat function. Oh, okay, let's try this. So just cat, both of those like that, without the print function. Yeah, and that's the same as doing this then. Essentially, oh wait, what was the difference there? Yeah, all right. Well, we didn't get off track. Yeah, well, I'll making a note of it, Rick, to look it up. All right. Let's move on. Yeah, no, that's a good question. I should know the answer to that. It's just not something that I've had to do. All right. R comes in a lot of has a lot of built-in mathematical functions and values, and some additional comparative operators. So just some standard things like getting the mean or the variance. There's built-in functions for that. The median, the absolute value, the square root, exponential value, some trig functions. And then for values, there's things like pi's built in, infinity's built in. And then these comparative operators, which we've already seen. This is more of just a list to refer to. We've got less than or equal to, greater than or equal to. Here, again, we covered this. It's equal to is those two equal symbols. Not equal to is exclamation point, then the equal symbol. All right. And then whenever we want to make multiple comparisons, we could, need to use the and or the or. So if we want to do essentially two comparative operations, we could say we want values that are equal to this, or is represented by the vertical pipe. If we want two conditions met, we'll have to use and that's just an ampersand. So here we've got the built-in heights vector. We can do something like mean heights, right? So it's 1.728889. Something like there. So you can see we have a variance of 0.0299. What would abs do here? All right. So no negative numbers in there, so it's not returning anything different. All right, so now that you have kind of an understanding of how those work and the fact that they exist, use the code chunk to convert heights vector, which is in meters, convert it to inches and save it as a new variable named inches, and then calculate the mean and variance of the new vector. So this is the last exercise in this topic. So go ahead and if somebody wants to write out the line on converting this and share it in chat, it'd be a nice competitive race without looking at the solution. All right, so we have 2 saying inches is equal to height times 39.3701 print, that's 2 inches. Yeah, that seems right. What's in the solution? Ah, yes. All right, so yeah, about, I mean, really close, just some slight differences. So then we do awesome. And then if we want to get, what is it, the mean and the variance, we'll do mean inches, var inches. All right, good job, everybody. Everybody happy with oh, something's off. With this variance. Anyway, I'll have to look at that. Everybody happy with these functions and well, really subsetting how to convert to integers. Oof, you could use the round function. Print, let's see. All right, but those still are numeric. There should be something like so in R, we have to specify, integers are really weird. They're specified with the number followed by an uppercase L. All right, so here, yeah. We had to do the round to convert our values to inches. We had to first round off so that we'd get the correct integer before we applied the as.integer function, because the as.integer function just lops off all of the decimal points and doesn't round up or down based on whatever's preceding the decimal point. Does that make sense? Let's see. All right, so you can see that there's going to be some slight differences between these values because without applying the round function, as.integer just lops off whatever the end is rather than printing it off, rather than rounding it and then converting it to an integer. Okay. Did I say that well enough to be understood by everybody? All right, let's go ahead and move on to, if there are no questions, we can move on to the next topic. All right, so let's start with dplyr. This is a really great package, regardless of what discipline you work in, for manipulating data. This package is part of the tidy universe, and they consider it the quote grammar of data manipulation, unquote. So it really does provide just a lot of functions for sorting and subsetting and filtering and, excuse me, manipulating your data, which we'll cover in this section. The first thing that I'll need to introduce you to is a new operator called the pipe-like operator from the package, I think it's Magritte R. And so this pipe-like operator, which is percent greater than percent, operates as a pipe, essentially feeding data from the left side to the first argument on the right, so that whatever function we're calling here, when we have to specify the input data, if it's written with this pipe-like operator, then you don't have to specify the data in the second function. So it's really useful for chaining things together, for chaining together several functions and making it look a lot cleaner than having everything on one line. So for example, down here, where I've got as.integer round heights, these multiple functions within functions within functions, that can get really hard to look at and hard to interpret. Whereas the pipe-like operator will clean that up and make it look, make it a lot more easy, or make it a lot easier to interpret. All right. And then here, let's just, this is, I think, a fun little bit of trivia. The package Magritte comes from the artist that did this work of art, Rene Magritte, which says this is not a pipe. Right, so that's where we get this functionality from and where the name comes from. So thanks to Josh for teaching me that a year or two ago. All right, so let's take a look at how this works. Essentially, these two lines of code are equivalent. So here we've got a new Star Wars data set that we'll be using. And if we print this out, the output's going to be exactly the same, right? So running head on the Star Wars data set would be the same as running Star Wars and then piping that into the head function. All right. Does everybody understand how this works? And a thumbs up if you've got this. You don't have to understand why it's beneficial yet, but just how this works. All right, thank you, Lauren. Thank you, Paige. Thank you, Elizabeth. All right, now where this comes in handy is again things like this, where we start having multiple functions called within functions called within functions. All right, and so this is really difficult to interpret what's happening here. Right, so I know I have to go to my innermost parentheses to kind of start figuring it out. It looks like there's a subset here I'm calling, and I'm looking for, I guess maybe I'm doing some sort of calculation with mean, and then I'm doing some sort of what's called a summarize function, and then rounding that. All right. So all this line of code, which is really hard to digest, is the same as this, right? Where I'm essentially creating this new variable, and then I'm piping the iris data set into these different functions. So first I'm going to subset and grab only the species Setosa. Then I'm going to pipe the output of that into this new function called summarize, and do what I need to do here. And then taking the output from that and piping that into the round function, and then specifying the number of digits I want to round to, right? And so this is much easier to interpret and identify what's going on, what we're doing. And so whenever you write code and then come back, to like 2 months later, this we could figure out in like 5 seconds what's happening, whereas this is just a mess. All right, but the output is the same. All right, so here I want you to take a little bit of time to play around and get used to this pipe-like operator and the Star Wars data set, and then complete these steps. So the first thing I would do would be something like head Star Wars. All right, so now we can see we've got names, these different characters, their heights, something, maybe mass, hair color, skin color, eye color, birth year, sex, gender, homeworld, species, so much data there. All right. Now, the first thing we want to do is subset the data to only include characters from Naboo. So I'm going to create, I'm going to go ahead and assign the output of this to a new variable, and we'll name it, I don't know, Naboo is going to be equal to, and then I'm going to take that Star Wars data and then start piping that into these different calls that we need. All right, so on the next line, just to make this clean looking, you can continue on the first line, but I like to do multiple lines to make it clean. We want to subset the data to only include characters from Naboo. So we can do a subset function that we learned, and then we'll say here we're looking for homeworld is equal to Naboo. And I'm going to go ahead, and when I write code, I like to do it in chunks like this, just to make sure that everything's working as expected. I'm going to do head Naboo here. All right, and it looks like I've got 6 rows, and these are all the characters from Naboo. All right, so that includes R2-D2, Palpatine. I didn't know Palpatine was from Naboo. It's been a while since I've watched those. Padme, and then of course Jar Jar and Roose Tarples and more. So, all right, so that seems to be working. So the next thing we want to do is pipe that again and remove R2-D2 from the data set. So here we'll do another subset, why not? And we'll say name is not equal to R2-D2. All right. And then subset again, All right, and then this is where it might get tricky, whose height is less than 195 centimeters or greater than 200 centimeters. So we'll say subset height is I think that's written backwards. We'll say greater than or equal to 195. All right, now here's where we need to use a new operator that I showed you, but we haven't used yet. What's the operator? Yes, Lauren, it's the vertical bar, or height is less than or equal to 200. And then if we do, let's just say print Naboo 1. Let's see what happens. It's not or though, is it? That would include too many characters. So this is written incorrectly. I need to fix that. If we run this now, if we want height between those, they have to meet both criteria. And so between 195 and less than 200. So that's my fault. I need to fix this in the notebook. Oh man, my Jar Jar Binks joke fell short because of a typo. So we could do less than or equal to, or greater than or equal to. All right, Rick's got a question. Let's run this again to make sure. No, that was not right. Object name not found. Can you put in the line that you were trying? Yes, you need to pipe after every line. Thank you. All right, so after every line, we're piping the results of that line into the next function. All right, and then to print out just the name, we can change our command to this. And remember that $ operator is going to go in and grab that column and just print out Jar Jar Binks. All right, are there any other questions or issues? It can be over anything we covered. I think we're at a good stopping point for lunch, so I don't want to introduce all of these new functions and then go to lunch, since we only have like 5 minutes left before that break. So if there are any questions over what we've just covered or anything in general, now would be a wonderful time to ask those. All right, so Rick saying object Naboo not found. Can you print or put in the chat the code that as it sits now? Naboo equals Star Wars. All right, I'm just going to try copying your code and running it. All right, Naboo equals. Oh. So you don't need the pipe on the last one. So it's still trying to define. All right, so since you have you had a pipe here, then Naboo is still trying like this. Naboo is still trying to be defined, so you wouldn't need to include that. You would just do head. Or you can remove this pipe. That way Naboo's found, and this should run. All right. No, that's super. It's super easy to do stuff like that. I still do it all the time. All right. Any other questions? All right. Well, okay, with that, thank you very much. I think we'll pause for lunch break, and we'll be back at 1:30. So in the meantime, if you have any questions, feel free to put them in chat, or I'll leave my headphones on for a few minutes in case anybody has any questions they want to talk about or issues. But other than that, you can take your lunch break. We'll be back at 1:30, and we'll start to get some really cool stuff after lunch. So thank you, everybody. Frames that have the same row names, do you think there's a function that allows you to combine those? Just based on kind of the way we've seen nomenclature go for naming things in R. Well, R bind allows us to contain two rows. C bind allows us to glue together columns. R bind is far more useful because it's from what I've seen at least, it's far more likely that you're going to be adding in additional samples rather than adding additional variables from a different spreadsheet, right? But that does exist, but it's just not as common. All right, and so like we mentioned earlier with this data set, we're missing that batting average statistic. So again, what we'll need to do is generate the statistic using the mutate function, right? Where we're going to say our batting average, or BA, is equal to hits divided by AB. And so now we can see we have this new batting average. And again, we want to clean that up so we can feed that into or have a round function in there as well. And once we have that, we've got what is typically shown for batting averages is 3 digits. All right. So again, just a bit of a refresher for using that mutate function, which allows us to add in that variable. All right, now, one weird thing about this data set, right, is the name of these columns, right? 2B and 3B. So let's go ahead and take a closer look at this, and we'll try to just pull out this doubles column, which is represented by the number 2 and the letter B with a $sign. All right, and R doesn't like this. All right, so the reason it doesn't like this is because this column name is starting with a number, which it doesn't care for. So what we'd have to do, we'd have to maybe add quotes around it. There we go. All right, but that's, I don't like that solution. That solution may suit you. I would rename the column so that I don't run into this issue again. And so to rename a column, we'll use a function called rename, which is really nice and on the head. So here we're calling the NCAA data set that we created, and then we're going to set that equal to the output of this rename function, where again we're specifying NCAA, and then we're changing this 2B column to DBL. All right, and so now again we can see this was the 2B column. There's no quotes around it because we're not starting with a number, whereas with triple, the column that represents the number of triples, we have quote 3B unquote. All right. All right, so I think that you can take a minute or two now and kind of tie everything we've done together. Oh, our solution to changing the format is just putting quotes around it, kind of sealing it off, which is totally is fine. It's just not it may lead to issues further down the line. Wait, why did R change the column name during the R bind? All right, it didn't change the name, and this is why I'm bringing this up. So you can still see that after the R bind, well, let's go before the R bind, I suppose. So this is before the R bind. It didn't change the name, but these quotes aren't showing up if you do like head ACC. It's not showing up as part of the name. Whereas if you do print ACC, it's showing up with these quotes around it. And so they're kind of hidden, which can cause issues if you're not aware that they're there further down the line. Right, so it's something that's R is kind of like interpreting in different ways based on the function that you're calling, which is never a good thing. You want it to be kind of always interpreted the same way. So whether you need those like to call it with a $sign, you need the quotes around it. The quotes don't show up whenever you do head, but they do show up if you do print. And so just to remove all of that, it's best just to rename it. Does that make sense, Rick? All right. Okay. Thank you for asking and letting me explain that further. All right. But I think you have enough information now to complete the following independent exercise. So I'll give you a minute or so to do that. And if you need to like go back to dplyr or something to look up like how to do the summary or group by, that's totally legit. I'm probably gonna have to do that as well. So just take a minute or two and work on that. And if you get a solution before I start talking about it, please post it in the chat. It's fantastic. If you're able to do this, then that's quite a bit of manipulation and analysis kind of all rolled into one in R that allowed you to kind of calculate all these statistics based on the teams after importing data from Excel. Are there any questions? Rick asked about PIMDOS, and R is subject to PIMDOS. That is correct. So here's my solution. Is everybody okay with this? So if you're familiar with baseball, if you're just looking at these, having maybe looked at just these statistics, you can see that there's going to be a lot of correlation between these observations, right? The more home runs a player has, the higher that slugging percentage will be, and the higher the number of RBIs. So to start looking at like correlations in data, we can use some of the like built-in functions in R, including the plot. And these built-in plotting functions are really great for just like doing general explorations of data. They're not great for producing high-quality plots, which we'll get to in the next section. But just in general, if we just plot here the batting average against the number of RBIs, and then I've just labeled the x-axis as batting average and the y-axis as RBIs, we can see that there's going to be some sort of correlation here, right? And so it's a real quick, easy way for us to examine the data without having to worry too much about plotting to make it look good or look pretty. Another function that I like for this is called the pairs function. And so here I'm just creating a new variable and then just essentially subsetting this NCAA data frame by this vector of these different column names. And so if I run this, oops, we select and run this. it produces this nice series of plots where so for example, the number of at-bats, or AB, is plotted against the number of runs. AB is plotted against H here, the number of hits. AB is plotted against RBI. And so we can see the relationship between all these different pairs of variables inside of our data set quickly. All right, so that's a real quick, let's say just like visual, non-quantitative approach for looking at these similarities. So since these appear to be correlated, we may be able to use them to predict if we have like the value for, say, slugging percentage. We may be able to use that to come up with an estimate for the number of RBIs that player should have. And so here we can use linear regression to accomplish that. And linear regression in R is just called using the LM function. And here we're saying RBIs as a function of the slugging percentage. And we're going to tell it our data is the NCAA data. And then lastly, we want to pull out a summary of the model that we created. So it does this very quickly, produces things like the residuals, the coefficients, the residual standard error, the degrees of freedom, the R-squared value, adjusted R-squared, all of these different statistics. I'm not a statistician, but we can go through these a little bit. So essentially we have the call, which is the formula used by R to fit the data. The residual is the summary of the difference between these values predicted by the model and the actual values themselves. So we have these sorted into different quartiles and then min and max differences. The coefficients, so essentially the estimates and how those are plotted into, or how these are represented in the model. And then our significance value. So both of the the intercept and slugging are both highly significant. All right. So now we've got what looks to be a fairly decent model for predicting RBIs based on the slugging. So if we include it, now we want to test this model on a bit of data that's not included in the data that was used to generate it. We'll have to read in some new data to do that. So we're going to have to read in a new file. We're going to call it test data is equal to read Excel what was the name of the file? Data science. And then give it the sheet, which is equal to test. And then we'll just go ahead, we'll click on test data. All right, so now we've got this additional set of data that we can use to test our model. So now what we can do is use the predict function to generate a list of RBI values for each of the players in this new data set. And to do this, we're going to take our test data and we're going pipe that into a mutate function. And we're going to say this new variable named predicted RBI is going to be equal to the output of this predict function. And we're going to have to feed in an RBI model, and then we'll have to convert the slugging, which is the test data slugging percentage, as a data frame, because it's required. The predict function requires input for a data frame. But once we do that, then we'll have this new variable stored in our test data set. So we run that, and then we can calculate the standard error using this formula, which we don't have time to go into, but is the formula for calculating standard error. All right, so we have a residual standard error. It's a little bit higher than what was predicted from earlier, and that's just because we're testing with new data. All right, so we may need to do some work to reduce this standard error so that we have a much better predictor for the RBIs that a player is going to produce before we use it in the future. I'm just going to go ahead. We're running low on time, and I want to cover some of these other topics for sure. So there are, we can do multivariate regression just by adding in new variables that will contribute to RBI. So here we're adding in home runs, number of at-bats. And so if we copy this, create this new multivariate RBI model, our residual error now is smaller at 7.228. All right, and then if we test this now on our test data, all right, so we've reduced our residual error now from what was it, 17 down to about 12 by including additional factors for the RBI model using a multivariate approach. So I know I blew through that, but are there any questions before we move on? Yes, yeah, there's nonlinear regression in our I'm struggling just to squeeze in linear regression in this short of a course. But yeah, there's all sorts of built-in models for things like that. All right, thank you, Rick. All right, we have 35 minutes left. So what I propose to do is just a brief walkthrough of running a principal component analysis, and then let you kind of examine that further on your own, and then move on to data visualization, because there's a lot to cover in data visualization. We're not going to be able to cover everything, but the ggplot2 package is really powerful, and I want to cover some of that. So I am just going to briefly walk through this, doing this PCA. So essentially there's another data sheet, and you can run this on your own. You'll have access to all these materials. You already do, they're in your home drive on ACES. But I'm going to essentially read in a new data frame, and it's going to be similar to the carnivores one we saw earlier, except this one was with rodents. And then I'm pulling out all of the numeric data for that. And then to do a PCA, what we're going to need to do is we're going to need to transform the data to make sure it's appropriate for doing a PCA. And so we'll use this nice built-in function called log to log transform all of the data. And so now we go from things where like weight, total length, and tail length, hind foot, where these are kind of like spread all over the place, to kind of more condensed form numbers that are going to be much better suited for a principal component analysis. All right, and then principal component in R is real easy. All you do is call the principal component function. And so it's going to spit out your principal components, and then the standard deviation for each. And then here we've got the proportion of variance explained. So we can see that there's, this is already looking like a decent PCA plot. We've got 81% of the variance is explained by the first principal component, 13% by the second. So we have a cumulative proportion of the variance explained, but about 95% by the first two components. So if we want to plot that quickly without going into ggplot, we can use the auto plot function. And I'm out again. All right. Did anybody get a nice pretty plot? Hopefully you were following along. All right. And so we've got a really nice PCA plot already here. That's fairly decent without doing the whole ggplot2 thing to make it look really pretty. And we can already see some really nice clustering based on species by color. So porcupine falling out here. The prairie dogs, pretty big, falling out here. What is this? Guinea pigs. Some overlap between the gray squirrel and the brown rat. But pretty good PCA plot, all things considered. As well, a pretty high proportion of the variance explained within these first two principal components. So this PCA did a really good job of kind of narrowing down the variation and essentially finding the differences caused by these between species and correlating that with a single axis, essentially. All right. I know that was a lot, but I wanted to introduce you to how easy things like principal components and regression are in R. And then now we can move on to data visualization. So this is a really expansive topic. We could do a whole 2 days just on data visualization in R. It's one of its things that's really, makes it incredibly powerful and useful is generating graphics. And so there's some great resources for free up here. So things like R for Data Science is a free resource. ggplot2, these websites for those are great resources for whenever you're starting to plot things for publication or presentation or whatever. You may need to go and I always have different ideas about what I want to do based on the data, and I have to always look up new things to do in ggplot2 because there's it's so powerful and there's so much that you can do. But the basic structure and call for ggplot or the way ggplot works, rather, let's start there, is that it plots things in layers. And so essentially we'll have a layer that we're defining the plot, the data set that's going into it, the elements of that data set that we want to plot. And then we add an additional layer that provides the specifics of how we want that data plotted. Here we're calling ggplot, and the function is ggplot, even though we're using the ggplot2 package. We're pulling in a data set called mpg, and here we're setting our aesthetics, or what we want to plot is equal to displacement, or the size of an engine, and our y values as the city mpg. All right, all this line does, if I run this, that's fine. It just sets up the area to plot and what we're plotting. I have to run this additional one to add the layer of the actual points that we want plotted. So now if I run this, we get this nice plot of these points, and we can see that as the size of the engine increases, the MPG, the city MPG, decreases, which makes perfect sense, what we'd expect. So this is essentially what I've explained. Please take time to read that maybe later on if you need to go in and review. If there are any
Sorry,
questions.
before you go further.
Yeah.
Sorry, can you please scroll up a bit? Scroll up. Yes. All right. Yeah. Before you run the code, this ggplot in brackets MPG AES. What does the AES mean? What function is that?
Is the what's called the aesthetics.
What does it do?
It is the things that are plotted that we can assign it's the things that are essentially, in this case, it's the X and Y values that are plotted that we can assign physical characteristics to inside of the plot. So here, geom point is assigning points to these values.
Okay.
This point right here, these aesthetic values.
Okay.
Okay, Elizabeth, this is very kind of complicated, and it's hard for me to explain exactly what how this works. Hopefully we get to a point today to where it starts to make more sense. But yeah, it's essentially
I've seen it. It's aesthetics.
Yeah.
I've seen it, and okay.
Okay.
Yeah, YX is displacement, and the C is the I think it's the city also. But
yeah, city miles per gallon is what it means.
Yeah. Thank you.
So yeah. So yeah, right here, the aesthetic mappings describe how variables in the data are mapped to the visual properties of the different geomes, which are those different layers that we can add. And so we can control these different these different aesthetics in each different layer. All right, so if we just let's just take a look at the MPG data set. We have displacement, which is the size of the engine, manufacturer, the drivetrain, the city miles per gallon, and the highway miles per gallon, the class of the car, so whether it's a compact or SUV or truck. So if we want to create a new plot, we can plot, we'll call the ggplot function again. And you can do MPG is the data frame. And then once again, we need to assign our aesthetics. And we're going to say X is equal to, let's set it to city. Y is equal to, we'll call highway. All right, now if I just run this, all right, nothing happens except for the plot's initialized. and I'll have to go in and add another layer. And you can see that there's all sorts of different geom layers that you can add. All right, we're going to keep it simple right now, though, and just add in a geom point layer, something that we're familiar with as we get used to kind of the syntax of these, the ggplot call. All right, and so you can see now there's a really strong correlation, as we'd expect, between the highway and city miles per gallon. All right, so now we can start to change the look of our plot and the shape of those points by changing these different values that correspond to them. So things like alpha, which is the transparency, the color of the point, the fill. We can change the group, the shape, size, and stroke. So if we just take a look at this right here, we're defining our aesthetic values, but we're doing it down here. We can do it by layer, or we can do it up here, and it's inherited by this layer, or we can define them actually within this layer. So here we're defining our aesthetics within this layer, and then we're going to control the output of these geom points. So we're saying the color is black. We're setting our size to 2, our shape to 21, our fill color to red, and our stroke to 3. So let me just run this so you can have a better understanding. All right, so right now our color is black, and that corresponds to the border. The size is 2. If we make that bigger, we'll obviously get bigger points. All right, the shape is 21, and I'll go over that a bit more in a minute. But there are different shapes that you can do that have corresponding numbers. The fill is what's in the middle, right? So we can change this to, say, purple. And the stroke is the thickness of the border. So if we want to thin that up, we can do that. All right, so just lots of ways to quickly change the kind of the overall look of your plot. Certain shapes, only certain shapes can take these stroke and fill values, and those are 21 through 25. All right, if you wanted to use these other shapes, you can't include those values as arguments. All right, so with that, why don't you take a few minutes and create a new plot mapping the displacement and the highway values from the MPG data frame, and then change these different variables, the shape, the size, the fill, the stroke, all of that, and come up with a kind of a unique plot. I'll give you a couple minutes to do that. And then if you can, please post your solutions in the chat, and we can take a look at them. I think that would be a lot of fun. And we're sitting all right with time right now. So if we can have a good understanding of this, then I think we'll be sitting pretty well as far as getting a good intro to ggplot. So take some time and come up with a plot, getting comfortable with that syntax and changing all of those different variables. All right, so I cheated. I just copied and pasted. But I'm going to start making some changes here. And what I'll add in the alpha so we can look at that. Maybe change the shape to 5. Let's do the pill. What's a color? Sky blue a color? All right. Rick's put something in the chat that I think I'm gonna like. All right. Excellent. Nice Aggie themed plot there. With a nice comment. All right, Peter's put in something. All right, yeah. All right, so great. Good job. That just getting to that point with ggplot can be difficult. So so now that we have that down, you may notice that like this, like our labels here are kind of meh. And so we want to improve those. Maybe add a title to it as well. Well, those are done in ggplot by adding additional layers to the plot itself. So here we're doing, I'm going to take Rick's, because I am an Aggie. And I'm going to add in some additional details. So estimated, here we're doing highway miles per gallon for the title. So I'm just calling here, I'm adding this additional layer called GG title. And then in parentheses, all I have to do is provide the title in quotes. All right, and then the key is after each layer, you have to put this plus sign and add an additional layer. So here I'm saying, all right, now I want the X label, X lab, right here, using that function to assign engine size and liters to that axis label. And Y lab is the miles per gallon. So if I run this, now I've got even a much nicer looking plot, right? With a nice title, estimated highway MPG by engine size. Our miles per gallon over here, and then our engine size in liters down here. All right. And again, say you want to do, let's do this. And just so everybody has an example of using the transparency, which I find to be helpful fairly frequently, run code. There we go. And so we can start to see where these things are overlapping. And that looks really good. All right, now, what happens if I do this? Is that going to be all right? Yep, it's fine, right? So we have, again, R is real generous with new lines, and as long as we're ending with a comma and it finds what it's expecting on the next line, that'll work, and it makes it easier to read. So I'll just go ahead and throw this back in chat. And so this will work if you have ggplot loaded. MPG comes with ggplot. So if you load the ggplot package, then you'll already have access to the MPG data frame, and you can just run this code real quick as a starting point for whatever you're trying to do if you're trying to generate a plot with points. All right. All right, so the next thing I want to show you, I'm not going to get too deep into it, but you can add labels to your plot using either geom text function or the geom label. So here I've actually, what I'm doing is just creating a smaller data set to work with so that there's not too much overlap. But I am essentially generating a very simple geom plot with ggplot2 in a smaller data set. So if I just run this, we can see we've got this much smaller data set that's plotted out. And then to add labels, I've just done plus geom text. And here, the aesthetic that we're going to be mapping is the label, which we've set equal to the model from the data frame. So now if we run this all together, we can see we've got now the actual model of each of these vehicles and where it ends up. And there are ways to adjust where these are showing up. We can move them up or down or sideways or whatever, or expand our plots to make it look nicer. We don't have time to do that today, but that's something that's you could definitely play with and figure out. All right. The last thing I wanted to show you, and to try to make the aesthetics thing clearer, is that we can add in additional aesthetics to be mapped, and that's going to affect how those are interpreted by the geome that inherits those. Oh, yes, you can use hex code. There's if you just Google like our code or our colors, it'll pull up everything that's available, including all the weird names it has, or just you can use hex code as well. It should work. All right, but here, this is what I wanted to point out, is kind of a last thing before we kind of conclude everything. Initially, we were only plotting like this 2 variables, displacement, the X and Y. Here we're setting our color is equal to another variable inside of the data frame, which is the class of vehicle. So if I run this, now we can see we've got this additional information here, right? So where our two-seater cars are going to be in whatever color this is, salmon. Our compact are going to be this brownish color. SUVs are going to be in pink, pickups in blue. And so it's adding in additional information to the plot that will allow you to actually convey more information by adding in additional aesthetics. So, and you can even take it further. You can say the shape is going to be equal to what was one of the let me look real quick. Let's say the drive. All right, and so now we're starting to add in, maybe too much information that it's not even readable. But again, we're by adding in these additional aesthetics that the aesthetics are what you can map to variables inside of your data frame. All right.
Thank you very, very much.
Did that help?
Thank you very much.
All
I'm
right, good.
appreciative.
That was that was what I wanted to get to for sure, to try to better explain aesthetics for you. So I think, yeah, that's about it. You can do histograms too. And you can make them look nice and do all sorts of different things. Let me go up here and show you one more thing that's not included. Let me see if I can pull this out of nowhere. There's built-in themes that will affect the look of the plot. All right. And so this is theme _BW, which just does gives it an outline, and the background's white now. Those are available. There's all sorts of different themes that you can Google and find a quick theme to make it look nicer really quickly. you may find you have like a favorite theme or something like that that you always include, just so that you're aware that those exist before we break, essentially. So I think right now that's about all I can cover. I know we ran through a lot today, and so I really appreciate everybody's patience and stick-to-itiveness, if you will, and staying around and participating. It's been a real pleasure. Are there any questions over anything we've covered today? All right.
Sorry, so essentially for the team, for the last task that you did, for the last command you ran, I mean,
Yeah.
for the team, so we can just I guess the BW is black and white, so we can actually combine any color to have the frame and the background, right?
You know, I would just maybe hold on, let me Google ggplot themes. So there are these different predefined themes that you can use. So theme BW is one of them. You can't just combine any colors, right? But you can, if you like theme gray or theme line draw or theme light, theme dark. Let's try theme dark. But they're all predefined, or you can you may be able to go in and modify those. Right.
All right, I see. Thank you.
Okay. Yeah. Yeah. I like that one, I think. All right. So thank you, everybody. Please take time. We have a very, very brief survey located here. You can follow the QR code. Rick's asking if we'll have access to the course info through ACES after today. Yeah, generally you'll stay on the ACES education allocation for at least a month, if not longer. And you'll have all of this is saved in your home drive. And you can just go and actually just, if you want to, just copy this to your own like personal computer and play with it, or just access it through ACES. You are that will be there. And then if you have any questions, you can email help@hprc.tamu.edu and I can get back to you, or somebody will get back to you. So it should be available. So but please take the time to fill out the survey, and if there are things that you would like to see included or maybe removed, or any comments you have, I look at those and try to incorporate that into future manifestations of this type of course. So please take the time to fill out that survey, and thank you all very much. This has been a wonderful experience for me. You guys have been, even the thumbs up helps a lot, so appreciate it a lot.
Thank you.
Thank you. If you have any other questions, I'll hang around for a few minutes and I can answer them.